All right, this is W11, solve equations with variables on both sides. All right, so before we actually start by talking about variables on both sides, there are a couple strategies to use when you're solving equations in general, okay? First, we want to focus on distributive property, if possible. Next, you want to look for like terms and then combine like terms. And again, if possible, right? I cannot tell you what the equations are going to look like. And so sometimes you need to use these strategies, sometimes you don't. But those two things, combine like terms, distributive property, if it's available for you to do, please do them first. And then finally, when you get to the part where you can start moving things from side to side, you want to use the inverse to move variables from one side to the other side. Right? And you notice I'm not telling you to move it from the right side to the left side. So when I go through these examples, I'm going to explain why I'm choosing which side I'm doing. So it'd be really great if you pay attention to that, because I'm not only showing you the steps to do these, because each equation can be solved multiple ways. But when I look at an equation, I actually think, before I start, I think to myself, which would make sense. So for this first example, I could add v over here and then add v over there so that they cancel out and then start solving it. But if I do that, then I get 0 here, right? Negative v plus b is 0 equals 8. And then negative 2v plus b is a negative 1v. And then I get this weird thing, which you could definitely solve this, because 0, you can think of it as a constant. So then we can move the 8 to the other side by subtracting it, so that they cancel out, and then negative 8 equals negative v. And then you employ this little trick, because you don't want to find negative v, you want to find a positive v. So you can multiply by negative 1, because a negative times a negative is a positive. Then you have to do negative 1 on the other side, so that positive 8 equals v, right? That seems like a whole bunch of work for an equation that looked pretty straightforward. So when I look at an equation like this, I see variables on both sides, and I see here that this v there is pretty much isolated already. It's on that side, it's on the left side by itself. So I want to move all the v's to the same side by itself. So this is the way that I like to solve this problem. So negative v plus positive 2v is now positive 1v equals 8, and then those 2v's, negative 2v's cancel out, right? It's a lot quicker to solve it that way. You do get the same answer either way, because I'm using the same strategies we use to solve equations, but understanding what the equation is asking for, understanding, or actually looking at the equation before you start solving, it can give you insight to finding the most efficient method for solving it. Right. So in this example, I'm going to move the 3d's over, because these d's are already isolated on the right side by itself. So I'm going to combine the d's. So 8, 3d minus 3d cancels out. 4d minus 3d is a positive 1d. All right, so 8 equals d, or d equals 8. All right. Here we have also solving for D, but now I have more terms. I like to try to combine the variables first, but if you want to combine the constants, that doesn't make any difference, okay? But I like to combine the variables first, so I'm just going to move the 4Ds to the left side, kind of so that our final answer says D equals something. So all the D's are on the left side. Those cancel out over there on the right. Negative 5D plus 4D is a negative 1D. Plus 1 equals 2. All right, so I can subtract 1 on both sides. 1 minus 1 cancels out. Negative D equals 2 minus 1 is 1. So now I'm going to multiply both sides by negative 1, so that my negative D now becomes a positive D. Negative 1 times negative 1 equals negative 1. All right, I do want to show you I do like to combine the variables first. To me, that makes it look a little easier. But if you want to combine the constants, right, like I can choose the 1 here. Let's choose this 1. Move the 1 over so that 2 minus 1 is 1, minus 4D, and let's add 4D, and then we get the same thing. And then I'll multiply everything by negative 1 so that D equals negative 1. Right? I can move the variable first or the constant. Usually I like to do the variables first so that you can try to isolate it, like actually think about that more. But either way will work. And sometimes, at least when I was a student, I found it fun to try to solve the same equation different ways. It just gives you a deeper understanding of them, and then you have a lot more mastery of this concept. All right. So this next example, that one thing that I mentioned, like if possible, let's please do that first because it just makes it more efficient. So I'm going to do, I noticed before I started, I noticed that on the right side, you got 10Ds and then plus 3Ds here. So if possible, combine like terms. So it's 13D plus 5, right? If you don't combine like terms, then you're gonna just do extra steps. You will get to the same answer though. But I like to keep things efficient, so let's do it that way. All right, so subtract 13Ds on both sides. Just because I kind of like D's on the left side if possible, so that the answer looks nicer. All right, so 10D minus 13D is negative 3Ds, minus 7 equals positive 5. All right, so now I'm going to add 7 on both sides, because it's just a two-step equation here. And then negative 3D equals 5 plus 7 is 12. And since it's negative 3 times D, let's divide by negative 3 on both sides. And then D equals 12 divided by negative 3 is a negative 4. All right, because those negative 3's divided by negative 3's cancel out. So D equals negative 4. All right, this is a final example here. It's just got parentheses. I noticed it's also got combined like terms. Like we combine these two terms right there. So you have 3.6p plus, all right, let's combine those two together. Pull up a calculator here. 9.14 plus 4.59 equals 13.73 equals negative 5.47 minus 2.8p. All right, I want to combine my p's, so let's move the 2.8's p's over so that cancels out. Let's move it to the left side. All right, let's pull up the calculator again. All right, 3.6 plus 2.8 equals 6.4 p's. 6.4 p's plus 13.73 equals negative 5.47. Okay, so now let's subtract 13.73 because it's just a two-step equation, so we're going to move that constant to the other side. All right, so now these cancel out there, and then 6.4b equals, let's see, 5.47 with a negative minus 13.73, negative 19.2. All right, so now we're going to divide both sides by this 6.4 so that they cancel out, leaving us just p alone on the right side. Now I have 19.72 negative divided by, whoops, I gotta do divided by 6.4. So divided by 6.4 equals negative 3. All right, so none of these examples use the distributive property. I do include that because you could have an example that does require distributive property and combine like terms, and then you also got variables on both sides. All right, you really got to practice these skills. Mastering these, I think, is super fun because you can take a complicated problem with as many steps as possible and still keep using the same strategies. And again, the strategies you're going to use are distributive property, combine like terms, and then use the inverses. Use the inverses to move variables, use the inverses to move constants, and you keep doing those until you get to a final answer. All right, good luck.